Welcome back. It's good to see you being back. I hope you had some chance to take a rest and be ready for the next speaker. However, before we go to the next speaker, I would like to announce that there has been new information posted on our website under the CTF section. The new information allows you to view the current leaderboard and see who is currently leading, who are the first three. How the fight is ongoing, you can see this there in the leaderboard web portal, and I will also cover this at the end of the day. However, our next speaker, Dor, is going to talk about the vulnerabilities in Kerberos in many products out there that have been used by you. However, he assures, don't worry, they have been fixed, at least the ones he's going to talk about. Now, Dor, welcome to the studio, and please, the cyberspace is yours.
All right, so hey guys, welcome to Spoof It's Gone, Exploding Kerberos and LDAP to Bypass Security Products. My name is Dor, and today I will be showing you how to exploit some of the most leading security products in the world just by using Kerberos. So before we begin, let me introduce myself. My name is Dor. I'm 9 years in the security scene, and for the past 2 years, I'm a researcher at Silverfort, and I specialize in authentication protocols. Just a word about Silverfort. Our unified identity protection platform prevents identity-based attacks both on cloud and on premises using protocols just like Kerberos and NTLM. This allows us to monitor and protect all users, service accounts, devices, and systems. The work on the vulnerability is a joint work with Yoav, Yaron, and Rotem from Silverfort, and Theory from Exclusive Networks. So let's discuss what we're going to talk about today. We're going to go through some Kerberos fundamentals. We're going to talk about 4 different KDC spoofing vulnerabilities. We're going to have some nice LDAP plot twist, and then we're going to talk how we can defend ourselves from these kinds of attacks. So let's begin. There is nothing like a nice history. So we can see that KDC spoofing is a very old vulnerability. A person called Doug Song posted POC code over 20 years ago when Kerberos was just introduced, and only a few expertise knew how to work very well with the protocol. In 2009, there was a Black Hat talk just about the same thing. And even now, 12 years later, people properly implement and work with Kerberos, and we can take advantage on and manipulate this for our own benefits. Let's see how. So let's go through some Kerberos fundamentals. Kerberos is an authentication protocol for managed domains. It was developed at MIT in the 80s. Version 5 was introduced in 93, and another revision was developed in 2005. It is mainly used in Active Directory, and it is very, very popular in corporate environments. Its TCP port is 88, and it works over UDP also. Its protocol components is the domain controller, the main service is the key distribution center. It has 2 main features, the authentication service, which validates the user's password, and the ticket granting service, which hands out service tickets to clients and servers. Also, there is a key tab, which contains a Kerberos principal and a Kerberos password hash, its server key, that of a specific server. Now I will be showing you how a typical Kerberos authentication works. so we can understand better later on the vulnerability itself. So in a case when a user enters its username and password, the client computes a password-derived key. This helps us to sign the authentication service request to the authentication service on the domain controller. Then the domain controller computes a TGS session key, ticket granting service session key, and TGT, ticket granting ticket, and hands it over back to the client. The client decrypts using its password-derived key the response, and now has the ticket granting service session key and the ticket granting ticket. Then the client now wants to, after its password was evaluated correctly, it sends a ticket granting service request to gain a specific access to the server. Now, when the request was sent, the domain controller now evaluates if the server exists. If the server exists, the specific service, it creates a server session key and a service ticket and hands it back to the client, sends a TGS reply to the client. Now the client decrypts using the TGS session key and sends an application request to the server, providing the service ticket. The server itself decrypts the service ticket, and now both of them have the server session key and can now have the ability to securely send authentication messages between each one of them. And this is a typical authentication process of Kerberos. In most cases, the client and the servers are the same. In what cases they are the same? For example, a Windows logon. When I myself go on a Windows computer, type in my username and password, the computer itself, instead of sending the application request to itself, just verifies using its own server machine key, and instead of sending the application request. Lately, in the past few years, we've seen applications, third-party applications, just do this. They send the authentication service request and reply back with a ticket granting ticket. This is just only part of the Kerberos authentication process. This part only just evaluate the user's password. But why we shouldn't do this? Because if we could stand between the server and the domain controller and perform and act as man in the middle, we can fake the ticket granting ticket replied back to the server. If a ticket granting service, ticket granting service is not returned to the server, then there is no actual validation that the server exists in the domain. And the application itself cannot verify that the application request is actually a real one and the domain controller is actually valid. So let's see how we can actually achieve this. If I'm an attacker and I put in the same exact username and I just make up my own password, I can create my own attacker's key, and the application will send an authentication service request to the domain controller. But if I stand in the middle, I decide not to hand it over back to the actual domain controller and reply with my own authentication service reply, the TGT. If there is no further valid, then I can just use any password I want to any application that doesn't validate the rest of the Kerberos process. So, well, you're going to tell me now, Dor, performing man in the middle is a very hard technique to use, and it's very unique in the world. So it's not as hard, but it's not also easy. But here are some examples that we can do man in the middle. For example, ARP poisoning, when we can manipulate the ARP table of a computer, the stateless address auto configuration, where the IPv6 NDR, we can attack the IPv6 DHCP protocol called NDR. We can spoof the DHCP response to a computer, replacing the DNS server and the default gateway. We can do DNS spoofing, and I think you guys got the idea. There are so many out there techniques to perform man in the middle. For the first part of the vulnerability, I'm going to show you guys the Palo Alto Network Firewall. Kerberos is used here for administrative access to the firewall and VPN. One of our customers came to us and said, Silverfort, I can't perform multi-factor authentication with your product on my Palo Alto firewall. Can you come here and see what's going on? So we opened up a packet sniff, and we just saw this. The first part of the packet sniff, we can see that Kerberos is trying to use UDP. On the second part, we can see that an authentication service request is sent to the domain controller. However, only the ticket granting ticket is replied, and the authentication ends. There is no actual service handed to the firewall, and there is no other validations that are very important to Kerberos. Then we went to Palo Alto manual, and then we saw that there are so many configurations to Kerberos. However, there is no key tab. And the key tab is very important because Windows clients can maintain their own server key. Third-party application needs a key tab to have their own secret key and validate the application request is valid. So now I'm going to show you a demo on how we can perform man in the middle on the Palo Alto administrative access. So on the left side of the window, we can see the Palo Alto administrative access login window. And on the right side, on the top, we can see the actual domain controller. On the bottom, we can see that our KDC spoofing server. For the simplicity of the demo, we performed some routing techniques just to show you how we can send the authentication traffic before it comes to the domain controller. So let's watch. So we can see that we use an actual password to log into Bob. And we have a success. The authentication was valid. And now we're logging out. Now we're trying to use a single note password. You can see that at the moment the password is invalid. And now we will turn on our routing technique. Just to show you that it doesn't matter which KDC is it is talking to, the password will be correct. So let's move on to the next product, the Cisco Adaptive Security Appliance. This is one of the most leading firewalls out there and used in the world. And Kerberos is basically used for everything: administrative access, virtual private network, SSH, and firewall sessions. Then we went again with one of our clients, one of our customers, to the configuration panel of the Cisco ASA. And again, what's missing here, basically? The key tab. There is no key tab for the application to validate the application request it gets from different clients. So let's continue to F5 Big-IP. I think you guys got the idea of this part of KDC spoofing. So let's continue to IBM Curator. This is a SIEM application that monitors everything that is going on in your network environment. Unlike the other firewalls, this application does request a service ticket, but instead of requesting a valid ticket to the curator, it is requesting an LDAP ticket to the domain controller to perform an LDAP bind. Before we continue to discuss this kind of spoofing, let's have a few LDAP terms so we know what we're going to talk about. So LDAP is a lightweight directory access protocol. The LDAP is mainly used to query attributes to the Active Directory, query, edit, or add attributes to the Active Directory. The main authentication is LDAP bind. We can communicate an LDAP traffic over TLS securely. And the LDAP bind was originally a simple password plain text. Later on, the SASL came on, simple authentication and security layer, providing the ability to perform Kerberos, NTLM, and other SSO protocols in order to perform the LDAP bind. So now that we understand Kerberos protocol, let's apply it to the curator. So the user enters its username and password to the curator, and this part is basically the same as a regular Kerberos authentication, and the service request is, instead of curator, is an LDAP bind. So after the Kerberos authentication is over, an application request providing the service ticket to the LDAP server is handed, and the LDAP bind is performed. So basically, if we spoof the key distribution center, why shouldn't we just spoof the LDAP server? It's the same thing. So if it was an attacker, I would make up my own password. I would send my authentication service request and perform the application server to a spoofed LDAP server. However, if you guys were smart enough to configure TLS, then I, as an attacker, won't be able to spoof the LDAP server, as I need the shared key. But then we went to our customer's environment, again, a different customer, and we saw all the authentication requests of Kerberos, but the service reply always ended up with a principal unknown error. We looked up into the configuration and we saw that our customer improperly configured its curator, and instead of inserting the net bias name required by fundamentally by Kerberos protocol, it inserted the IP address, but still authentication was successful. So if we go back again to the to our flow chart, then instead, when the reply, the service request reply the principal unknown error, it would just open an empty LDAP session, and then the curator would send an AS request, obviously, but the ticket was not valid. So there was no actual LDAP session, and the authentication was still successful. So instead of just spoofing the LDAP server, let's just return the principal unknown error. And again, we exploited successfully the curator. But you guys think that's the end? Of course not. Curator has a local database, users database. When you freshly install Curator, there is the first administrator username created, which is local. However, when you configure Kerberos, there's a logical flow that when you authenticate with the local username, it sends a request, a Kerberos request, to the domain controller to see if the user exists in the domain controller. It usually doesn't, because who has the user admin on its domain controller? However, if the user exists, the local database and the Kerberos on the Active Directory merge, and this user gains the root permissions to the curator. So this is very useful because we can spoof it, and we don't need to actually know which users does exist in the Active Directory to exploit the curator. So we've seen all these products, and all the vendors issued a fix to all of the vulnerabilities. Cisco ASA and Big-IP now require additional configuration to add a key tab file, but this is still not required. So if key tab was not added, then only the ticket granting ticket would be in use. IBM Curator, which was my favorite fix, removed Kerberos support completely, and instead using just LDAP, securely LDAP bind. So lastly, what can we do about it? So first, patch and reconfigure. Make sure the configuration is full and your firewall is up to date with the latest versions. Wherever you can, use LDAPs, use TLS for LDAP. Make sure you have applications to monitor Kerberos and defend yourself from Kerberos attacks. Identify KDC spoofing. And if you don't have a key tab, that's very fishy. And make sure every time you configure Kerberos, make sure a key tab is inserted. So lastly, we developed in Silverfort a free tool, free of charge. You guys can download, run in your network and manage network environment, and insert an application IP address, and check if your application is vulnerable to KDC spoofing. Okay.
All right.
Thank you guys for listening.
Thank you. With this, we return back to the studio. Thank you, Dor, for a very in-depth talk in explaining how Kerberos works and how can you actually bypass this. And it's really interesting that you can just impersonate another Kerberos server and just tell, hey, you are all good, right? However, for sure, as I understand, there are multiple preconditions that you already mentioned that you need to be on the local network to have the man in the middle position or interfere somehow with the traffic. Additionally, the data exchange should be not encrypted, right? So if there's an encryption, then it's already an issue to kind of eavesdrop and modify or answer back provide the right answers. Or there are other conditions that are needed to be met prior to attack.
So basically, for KDC spoofing, for Curator specifically, if you use LDAP over TLS, you don't need extra. You can't manipulate LDAP over TLS, as far as I know.
Yes.
But for just KDC spoofing itself, all you need is to be a man in the middle between the server and the main controller.
Right. So from the defense perspective, as you already said, the layer 2 defenses could be one of those critical ones. So having, I don't know, DHCP snooping or some ARP spoofing protection. So that would be anything in addition to this. Is there some auditing or what we can think about to kind of strengthen or do proactively identify vulnerabilities in these devices?
So the free tool I've developed freely uses auditing over domain controllers just to find where an application is improperly using Kerberos.
Right. The vulnerabilities that you explained were discovered by you and reported by you. Is that correct?
It was reported by me and my team.
Yes, perfectly. Can you explain on how this process went for you? Did you experience, what were your experiences when reporting it? How did it go through? Were the vendors forthcoming or how did it go?
So, well, it all started when we went to our customers and they were having trouble performing a multi-factor authentication layer on using our service on their third-party applications, firewalls, and etc. So we went and we looked, and then we actually approached all these vendors, and they worked with us and tried to understand, because we, as an identity startup, we are very working into the protocols, and we know how the protocol should work, and we can offer how to patch it. So when we approached, we waited for the vendors to issue fixes, and once they patched all the applications, we published the
published the vulnerability
the vulnerability
yes.
itself.
Yes. Thank you. So I understand everything started with, what can you, I don't say an accident or responding to a feature that didn't work out, and this is what sparked finding this vulnerability.
So yeah, basically it was customers are having trouble using their application, integrating their application with ours.
Have you checked it against, so you already provide a huge variety of the most popular products that you've assessed. Have you checked it against a broader scope of the products, or these are just the ones that are out there, the most common and used by millions of customers?
So I believe there are so many applications in the world properly implementing Kerberos. So I think it's very broad, and I wish I had the capacity to check all of them myself. But right now we checked all of those big ones. For example, Curator, we even found more to the KDC spoofing than we actually hoped to find.
Right. I have, as a final question, and this comes to from our audience. And the question is, would employing host-to-host IPsec be good just in case there's spoofing vulnerability practice? So host-to-host IPsec.
So I believe, so Kerberos is mostly on managed domains. So this has to be in a managed environment. Does that answer your question?
All right. I hope this is some answer, but most likely you may take it up with the one who asked this question in the Discord chat as well.
All right. You also are all invited to send me an email, approach me on LinkedIn, Facebook, whatever you want.
Right. Well, thank you so much, Dor, for being here with us in the studio. And thank you for explaining the wonderful research you've done and explaining how it works. Perfect. Thank you so much. With this, we return back to our break. However, during the break, don't go away too far, because we will be returning back with automating the offensive pipelines. So if you are into offensive security or conducting red teaming activities, the next talk might be just right for you. We'll be back after about 20 minutes. All right, see you very soon.